All right, in lesson 8.1.1, it says, is the graph linear? So the word line is in linear, so we're talking about graphs that make straight lines. Patterns of growths in tables and graphs. Have you ever noticed that the sun rises early and sets later in the summertime than it does in the winter? If you live north of the equator, you have noticed that in December you often wake up for school while it's still dark. However, if you wake up the same time of day in May, the sun is shining. The number of hours of sunlight in any one place changes during the year, unless you live directly at the equator. This is because the Earth tilts, changing in comparison to the sun. The number of hours of daylight is approximately equal to the number of hours of darkness at just 2 times of the year, the fall equinox and the spring equinox. If you compare the average number of hours of daylight to the time of year on a graph, you will be able to see a pattern in the number of hours of daylight and how it changes. Today you will explore situations, tables, graphs that change in different ways and build strategies for visualizing different patterns of growth. As you work, think about the following questions. What happens when one measurement changes, and how can we see the pattern of growth in a table? We're going to take a look at question 8-1. With your team, discuss each of the following comparisons described below. Consider how the measurements are related and visualize what each relationship would look like on a graph. A, the month of the year compared to the average daily hours of sunlight in the northern hemisphere. So if we're thinking about this on a graph, here's our graph. Let's just go back to the question. The month of year compared to the average daily hours of sunlight in the northern hemisphere. So let's start in January, and then this would go to December. So this would be more light, and this would be less light. So in January, we wouldn't have as much light. And then in February, it'd be maybe a little bit more. March, maybe a little bit more. April, May, June, July, August. And then what happens in September? It starts to come back down so that in December, we're kind of about where January is. B, the number of months money has been invested compared to the total balance of the bank account that it earns simple interest. So if I'm investing money, I hope I'm gaining money over time. So if I sketched a quick graph, maybe it started down here at this point, and over time it should be growing, should be increasing in value. Letter C, the cost of an item that has price repeatedly increased by 50%. So this one's a little bit difficult. We might have to come up with a scenario here. So I'm just going to number this quick. If the item the first month costs $2, but then the second time it increases by 50%. 50% of 2 is 1. So then it's going to cost 3. So it's going to be 3. And then, since it's 3, 50% of 3 is now $1.50. So 3 plus $1.50 is going to make it $4.50 the next time. So this is going to not make a straight line because each time it's not going to grow by the same amount. It's going to make a curve, and maybe not quite as steep as the one I just made, but it's going to show exponential growth instead of linear growth. And letter D, the length of the base of a rectangle that has the area of 24 square centimeters compared to its height. So let's go back. It says the length of the base of a rectangle that has an area of 24 centimeters compared to its height. So it just depends on what the rectangle is going to be. We could have one that is, this is 1, and then it could have the height of, if its area is 24, it would have the height of 24, so that would be graph there. If it had the base or the width of 2, 24 divided by 2 would be half of that, so that would only mean it's at 12 there. If it had 3 as the width, 24 divided by 3 is 8. Now these aren't exact measurements. If it had 4 as its measurement, then we're down to 6. So you can also see that it's considered nonlinear growth. It's following a curve.